Today we're going to talk about proportional versus non-proportional. So the first thing we're going to look at is a table. The way that we're going to tell if a table is proportional or non-proportional is it has to have a constant rate of change. This can also be called a constant of proportionality. The way we find that is we have an equation down here at the bottom, k equals. Now k equals y over x. In other words, we could say k equals y divided by x. Now let's put that to the test up here. We're going to look at this table to begin with. So, using our equation, k equals y over x, first thing we're going to look at is 30 over 2. So let's try that. 30 on top over 2. So we then need to do top in, bottom out. 32. 2 goes into 3 one time. That's 2. Bring down 2 goes into 10 5 times. So we get 15 on the first one. But we have to see if it has the same rate of change for each one. So now we need to do the second one, which is 90 and 8. So we do top in, bottom out. 90 on top, 8 on bottom. And we can put top in, bottom out. 8 goes into 9 one time. And 8 goes into 10 one time. It's not even, but we know it can stop there because 15 and 11 are not the same thing. Since they are not the same thing, this is not proportional. Now, let's look at our next table. For our next table, we have y equals 1, x equals 5. So using our same formula, k equals y over x, we're going to do that, y over x. Okay, then we're going to do top in, bottom out. 5 goes into 1 0 times, but we have to add a decimal and a 0. 5 goes into 10 2 times. That's 10. So we get 0.2 as our change here. Now we can continue on to our next one. We have 8 and 40. So we have y over x, top in, bottom out. 40 goes into 8 0 times, but we can add our decimal and a 0. 40 goes into 80 twice. So we can stop there, and we get 0.2. Now let's do the last one just to be 100% sure. So y is 13 over x, which is 65. So we do the same thing, top in, bottom out. 65 goes into 13 0 times, but we add our decimal and a 0. 65 goes into 130. I can't really do that in my head, so I am going to work this one out over here. I'm going to try 2 because that's what our change is. So let's just make sure it is the same. 5 times 2 is 10. Carry the 1. 6 times 2 is 12. Plus 1 is 13. So we do have 0.2 here as well. So this table is proportional. The next thing we're going to look at to see if it is proportional is a graph. So for a graph to be proportional, it must have a linear graph, and that just means it needs to have a straight line. The next requirement is the graph must go through the origin. And that just means the coordinate 0, 0. That is the first thing in the graph that I would check every single time. So let's go up to our graphs and let's check. We're going to start with the left one over here. And the first thing that I said we're going to check is, does it go through the origin? And that means, does it go through this corner right here, 0, 0? This one does not, so this is not proportional. I'm going to put the reason that it didn't touch origin. Now let's look at our next graph over here. So the first thing that we check every single time, does it go through the origin? It's right here in this corner. It does. So we can write did touch origin. Then the next thing we need to look for, is it a linear graph or does it have a straight line? When you look here, it does have a very straight line. So this one is proportional. Sometimes when you're given a graph, it will ask you to find the equation of the graph, constant of proportionality of the graph, or constant rate of change. Now we remember from our last slide that we have an equation, k equals y over x. So we would just apply that to this graph. So we can go to our first point where it crosses the line in a corner. So we follow this and it hits a corner right here. So we follow the number line up and we hit 2, and then we go all the way over to 8. And that is where it touches. Y is 2, x is 8. So then from there we do top in, bottom out. 8 goes into 2 0 times. We add our decimal. Add a 0. 8 goes into 20 twice. That's 16. We subtract. And add a 0 to bring it down. 8 goes into 40 5 times. So the constant of proportionality, the constant rate of change, or k, would equal 0.25. The last thing we're going to look at to see if it's proportional or not is an equation. The most important thing is the equation must be in y equals kx form. Now there's a few things we need to make note of. This x right here, this can be any letter. And the k right here can be any number. Now notice, right here, when we have two things right next to each other, that is multiplying. So this is k times x. So we have to remember that there cannot be any addition or subtraction. So there can't be any add or subtract. Now this is very important, so I'm going to put a little star right by it so we remember that it cannot be any addition or subtraction in the equation at all. So now let's go look at our first example. We're going to look over here at this equation, n equals 450 minus 3p. So is the equation in the y equals kx form? So the big rule that I just told y'all, we can't be any subtract or add. Well, we have a subtraction right there. So this one is not proportional. Then I want to go ahead and clarify up here. That way you can remember on your notes that we can't subtract. Now let's look at this equation over here. D equals 65t. So let's see if that's in our y equals kx form. So y could be any letter, equals, k could be any number, so that would work, and then t, which is x, because we said x can be any letter as well. So right now, it looks like it's in perfect y equals kx form, so I would say this is proportional.